guys! I hope that you had a really nice Christmas and that you spent some quality time with your families, or that you had some time off at least from work. I lied in my last video when I said that I would see you guys next week, since that was 2 weeks ago. I obviously took some time off for Christmas, and I think I will also change my uploading schedule from weekly to monthly just for the next maybe few months, because I've got a few exams and it just works out a little bit better. In this video I really want to speak about anxiety. I want to be very precise in the way how I explain anxiety, how I define it. I want to explain it in a way where very technically minded people who may have a predisposition to feeling like anxiety is something that's maladaptive, not helpful, useless, or maybe even getting in the way of progressing in life. I'm going to try to use the analogy that's most often used when speaking about the brain, because I'm going to be relating anxiety to the circuitry in the brain and using neuroscience to explain things to you in a simpler way, which is to use the analogy of the computer. Anxiety is a little bit like the computer process of detecting threats. There are different mechanisms that are in place for the computer to be aware of this threat and to do something about it. This is in the same way of the human body. We have threat awareness and we have different mechanisms that I will go into and explain and set the scene for you guys that react to these threats. Anxiety is often treated as a personality weakness. However, we have something called normative anxiety, in other terms normal anxiety, which is a necessary process in order for us to be able to be reactive to the things that are going on outside of our environment that could potentially be threatening to us. It isn't a mindset problem, it isn't a weakness, it's just threat detection that help us to therefore change and adapt our behaviours in reaction to what we're seeing and what we're feeling. When it's working properly in the same way in the computer, it's there to protect you. But when it malfunctions, and there are multiple different ways in which it can malfunction, it can, for example, loop endlessly, as you might see in errors that are going on in the computer, or it might spam you with error messages, or basically make the whole system malfunction through kind of a series of domino effects. This is the same in humans when we have this anxious malfunctioning. And I'm going to go on to explain how the system can malfunction in your brain. First of all, I want to set the scene for what is normal and what is abnormal here. When we're talking about how a system is meant to run, in the same way that we have many different computers, for example, we have specific gaming computers, we have specific laptops, tablets, different devices that kind of have a different expectation of how they're meant to be running. So something that might seem wrong in one system might not seem that wrong in another system. This is what we need to ascertain in humans as well. What is the baseline for what's normal and what is abnormal? In the case of anxiety, we have normative anxiety and we have pathological anxiety, and these exist on a spectrum. When we have normative anxiety, or what we classify as normal anxiety, it's adaptive. Similarly to a computer, it's like having a firewall that alerts you to the threats that might be going on in the system. It lets you respond to them in a timely and calm manner. And then once the threat is gone, we have a reset process where we just go on about our days as normal. Pathological anxiety is maladaptive, so the other end of the spectrum. Everybody basically starts off with normative anxiety that might build up a small hitch in the system or a small problem, which then compounds over time or has some kind of building and growth to it, which then might build up to pathological anxiety. It's something along the lines of flagging normal activity as being suspicious activity, or the firewall sounding its alarms for the smallest things that would otherwise be normal. It's basically a loop that beforehand would have been adaptive, but now seems relatively stuck. As I mentioned, anxiety exists on a spectrum. Like a leg injury, the severity, location, and duration of the injury all influence where on the spectrum we place the leg injury itself. Not every case of leg injury requires the same kind of intervention.
Does he realize how much danger he is in just being here?
Yeah, God.
What? Look at that! Look at that! It's a miracle!
For example, a small bruise on your calf isn't going to need the same kind of treatment or the same kind of diagnosis as a broken knee. This is the same with anxiety. We have a spectrum of how severe it is and how maladaptive anxiety is, and that's based on anchoring it to what we classify as normal anxiety. When we have a malfunction in a system, what do? Well, we tend to run system diagnostics to figure out what the problem might be. Now, if you've ever run system diagnostics on your computer, you might see that sometimes the computer comes up with no diagnostics at all, or it might be unable to actually ascertain where the problem is. Now, that's completely normal. That's because there are limitations to how much a system can actually self-diagnose itself. That's why we often need to go to a psychologist or a psychiatrist or a doctor in order to help assess what's abnormal about the way that we're behaving, because we're already sensing some kind of issue. Why is it not so simple? Why can't we just classify humans into pathologically anxious and normative anxious? Well, if we see the comparison here between what a computer screen is showing us versus what a human is outwardly behaving as, these things are not so easily interpretable. Diagnostic criteria are just logs of outward behavior, so what the screen is showing you. They tell us which errors are showing, but not which processes are actually causing the errors. Two computers, for example, can showcase you the exact same thing on the screen, but have two completely different processes that have impacted what you're seeing on the screen. For example, one computer might freeze due to a graphics driver conflict, and another computer might freeze due to a background update, for example. But both present themselves as the same based on what you're seeing on the screen, which is a freeze. Current diagnostic psychological criteria is also kind of reductive in this sense, because it's only based on what we can see, based on what a person is behaviorally showing us. You can't always accurately describe why you're feeling anxious and whether it's maladaptive or not. So what do we need? Well, we need a deeper systems log. We need to understand the brain circuitry, we need to understand the computer circuitry to understand exactly where the problem might be. Neural imaging is kind of like opening the task manager for your computer. It tells us a little bit more about which processes are running, at what speed they might be running at and what intensity, as well as how the different systems are interacting with each other. Modern interpretation of neural signals have taken a more software-like approach, looking at the series of activations and the patterns which therefore define the function. It's not about which files exist in your computer or the specific parts of your computer when they're singularly taken out, but the whole ensemble of the computer itself and which processes are running and which parts of the computer they're using when they are running. So let's get back to trying to classify pathological anxiety and normative anxiety. We have two witnesses here. We have what we're seeing on the screen, so basically our behavioral logs, what we see in a person and how they're behaving, and we also have the task manager, or the imaging logs, or the neural images that we've taken, for example, functional magnetic resonance imaging, or other kinds of maybe electroencephalographies, which give us some kind of insight into how the brain is working in real time. Both are partial insights, but they overlap, so they give us some kind of congruency, and through that congruency we can deduce the mechanisms that are going on. But we still need a common language between these two readings, so between what we're seeing on the screen and between what's going on behind the scenes and what programs are running. What this means is that we have a set of behaviors that we then assign to different systems. It helps us map the things that are going on in the brain onto behavior. First of all, we have something called threat detection, or negative valence system. These are basically the components that are mainly active when we're assessing threats. In the computer example, this is the kind of processes that are used in order to flag errors or suspicious activity. There's also reward processing or positive valence systems, which are areas of the brain which are mainly active when we're processing rewarding information or positive information. In the computer, this might be analogous to kind of prioritizing successful operations or getting some kind of feedback loops that are positive, basically rewarding a computer for doing something well and fast. We also have cognitive systems, so kind of executive functioning, decision-making systems. In the computer, this is kind of like your CPU and allocation of attention and energy. We also have social processing systems. In the computer, this is kind of like how the network handles external communications. And we also have an arousal or regulation system, which is kind of like temperature management or power management within the computer. So we have a few different systems, and this kind of means that within each system there could be something that might be going wrong. One circuit within one specific system might go slightly awry and then result in something that appears like anxiety in terms of the behavior that we're seeing from another person. What psychologists do, or what good psychologists do, and what the research is trying to do currently, is to distinguish between the specific types of anxieties down to that circuit level, down to the part where is it actually going wrong, which specific system is being targeted in this specific anxiety, and therefore which treatment can be applied in order to help it. We actually need to be very specific in the very mechanisms that are being affected and target through drug therapy, through cognitive behavioral therapies, in order to rewire the brain. I'm going to just give one example of a system that might be influenced in a negative way, which might result in something along the lines of generalized anxiety disorder, or also a specific phobia, which helps you understand how these anxieties actually come about and how they can grow from very small problems in the brain or small changes in the brain that can therefore spiral if it's not treated in a timely manner, or even if it's perpetrated over and over again. I'm going to specifically focus on the threat detection system in this video. However, like I mentioned, there's also the positive valence system, there's also the cognitive system, we've also got the social processing system, which is really big for social anxieties, and we've also got the arousal and the regulation system, which seems to be kind of involved within all of these different anxieties to some extent, or can become involved over time. When we see a threat, we actually have two different pathways that activate. We have a fast, direct pathway, and we have a slightly slower but more precise indirect pathway. From our receptors, so however we're actually getting the input of the threat, we see the stimulus, it goes to our thalamus where most of our inputs kind of relay, then it goes straight to our amygdala. Through our amygdala, it goes to the hypothalamus, and the hypothalamus then also influences the autonomic system that we have in our body, which is basically the kind of automatic response that you feel like you're having when you sense a threat. Now, this is all happening on the unconscious level, so this is all happening before anything it goes to our prefrontal cortex where we're able to appraise it or give it some kind of cognitive and conscious decision making. This is our direct threat response. It means that we're kind of immediately alert and our sensory processing has seen something that has potentially previously been a threat to us, and we're able to capture it straight away and have our body react to it straight away. The indirect pathway, which might come as like a second wave, is also going through the thalamus and the amygdala. However, it also interacts with the hippocampus. It kind of adds the context that is missing from the potential threat that we're sensing. So for example, if you're watching a horror movie, you might have that initial reaction, that direct pathway activation that might make you anxious or jump. Then you might have that secondary context evaluation where the context of this being a movie on a screen and you sitting on the sofa and you being in a safe environment is added on. Then this indirect pathway goes through onto the anterior cingulate cortex and the prefrontal cortex, which basically helps you regulate your emotional response and also make some kind of decision. In the computer scenario, you might have an error pop up from something that you might have clicked wrong, and you might be able to review it with the computer, and the computer resets itself and says, okay, no worries, this doesn't seem like that big of an error based on the inputs that I'm getting, based on the user, and then you can function with the computer normally after that error pops up. Whereas in a dysfunctional or a pathological, let's say, anxiety computer, you get an error pop up and it continuously pops up without there being any modulation because there is no control the anxiety that it's feeling from the initial error. So therefore, one method of finding pathological anxiety in a human is to maybe see that they have some kind of augmented direct or indirect processing pathway. Maybe they have a hyperactive direct processing pathway. So that initial anxiety or threat assessment that they have that is unconscious and immediate basically is hyperactive and so strong that it overpowers that secondary modulatory response that is meant to happen, where it's actually evaluation and cognitive appraisal of the actual situation. Once or twice this might happen to a person and it might still be classified as something normal. However, when it happens over and over again, the person might feel a sense of lack of control, of being able to control their own attention. The stimuli that they see in the environment might be overweighted as threats consistently. And more importantly, even when there is no threat, they might still be constantly assessing the environment to see when the next threat might occur and being hyper vigilant. And I don't want people to think that this is an illogical process or that people with anxiety are illogical people. They are very logical people. They just have a normally functioning system that otherwise would function normally, but is functioning in the wrong way because of this one thing that isn't functioning properly. Unlike static software, brains can recover because we are growing biological people. Circuits can rebalance, and the brain eventually does want to rebalance. We can retrain our attention and our memories can be rewritten. This is why we have things like cognitive behavioral therapy and why we have drug therapies as well. It's so that we can target those specific areas that are needing to be helped and the specific circuitry that has been affected. And through understanding things in this kind of sense, in a systems level sense of patterns of activation and where activation might be hyper or hypoactive, we can actually target that with the specific therapy and help the person rather than just assigning them SSRIs or any other kind of typical drugs that are given as a blanket for all anxieties. So I've given you an example of how an issue within the threat detection and threat processing systems, the negative valence system in the human brain, and the change within it might actually cause the anxiety that we might see in the behavior of a person. However, there are other systems that can also be influenced and changed slightly in order to produce similar kinds of behavior. That's all that I have to say. I know that it's relatively reductionist and relatively short in nature in the way that I'm explaining it. Truly, I just wanted to create as simple of an explanation as possible from a neuroscientific point of view of what anxiety is, and to underline that it's not something horrible. I want to more normalize it as something that can be dealt with if we just put in the effort to pick it apart and understand which circuits are being affected and which pathways are being affected, and that we can actually provide more precise medical approaches and more precise therapeutic approaches as well to people with anxiety. So thank you, and I guess I'll see you guys next month with my next video. And make sure to subscribe. Thanks, bye.